Hey guys, today I'm going to give you an introduction to exponents. Today's going to be all about the basics of exponents. So by the end of this lesson, you should be able to write expressions in an exponent and an expanded form. And we'll learn about what those mean right after we learn about what are exponents and why are exponents important. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. Let's get started with the basics of what exponents are. So all of these numbers are fives with exponents. Each one of them has an exponent of 1, 2, 3, and so on. So an exponent tells you how many times a number is multiplied by itself. So for example, we already looked at a number squared. So 5 squared means 5 times 5. So you could write this as 5 times 5, and that would be 25. So this brings me down to this rule at the bottom. Every number has an exponent. If it doesn't show you one, it means there's a little invisible 1. So this would 5 to the first power is just a regular 5. So if it doesn't show you, every number that you have known so far just has a little invisible 1 exponent. This means that there is 1 5. This one means there's 2 5s being multiplied, so that gives me 25. So I'm jumping around a little bit, but I'm using some vocab here. Exponents and bases. Exponents tell you how many times to multiply the base. So the two words that are important today are exponent and base. I'm going to go through in green and just show you that the exponents are 1, 2, 3, 4, and 5 in these situations. Those are exponents in green because they're like the little number on top of it. So this is like your little flyer. I always think about this like it's cheerleader. These are the bases. The exponents are your flyers. So as you can see, I'm going to go ahead and red. The base is all of these fives. There's a base 5 for all these numbers. So these are just 5 different examples of numbers with exponents. What I want to show you is what happens when the exponent increases. So when we look at this one right here, 5 to the first power, it's just regular 5. 5 to the second power is 25. 5 to the third power would be 5 times 5 times 5. So it tells you how many times to multiply the base by itself. So if this is a 3, it means that I write 5 times 5 times 5, 3 5s, and they're being multiplied. So I can just start looking at one step at a time, going left to right, going 5 times 5 is 25, and then multiply another 5. 25 times 5, I can do without a calculator because I think about it like quarters, and I think if I have 5 quarters, I have 125. So far you can tell that when we increase the exponent just by 1 each time, my numbers went from 5 to 25 and jumped all the way to 125. As we increase the number of the exponent, we could say that our number is getting exponentially bigger. These are increasing exponentially. This is some of the vocab that you might start seeing in this unit. See if you can try for yourself, figuring out what 5 to the fourth power or 5 to the fifth power would be. Pause the video and then press play when you're ready to check. So we talked about our I can statement was writing the exponent expressions in exponent form and then in expanded form. This is an exponent form because I have a base and an exponent. And then when I write it out, this is expanded form. So I've written a 5 multiplied by itself 4 times. 5 times 5 times 5 times 5. A lot of people will make the mistake of saying 5 to the fourth power is 20 because they do 5 times 4. That is completely incorrect. Please make sure that you don't mistake this for multiplication. It's not multiplication with the exponent and the base. It's repeated multiplication of the base. So I'll do 5 times 5 is 25. Then I can do 5 times 5 is 25, and I'm multiplying 25 times 25 to be 625. I do the same thing for 5 to the fifth power. I can write out an expanded form, 5 times 5 times 5 times 5. Always double check and count. This is 5 to the fifth power, or with an exponent of 5. 5 times 5 times 5 times 5 times 5. So there's 5 5s. So when I write this out, I know that 5 times 5 is 25. I know that 5 times 5 is 25, like I just said. I know that 25 times 25 is 625, and then I had a times 5 at the end. So I can bring that down, and 625 times 5 is 3,125. So see how big these numbers jumped from here to here to here to here to here? Those are big jumps in these numbers. So let me show you this in a real life scenario. What if I was choosing to lock something up and I was choosing between these two types of locks? So these are two combination locks that have 0 through 9 digits in each place. And your job is to come up with a combination of any 4 random numbers for this lock and any 5 random digits for this lock. You probably already know that this lock is going to be more secure because if I was going to come up with 5 digits to crack into in a certain order, it would be harder to come up with 5 than it would be to come up with 4. But let's see how much more secure this lock is than this lock. It all has to do with exponents. So I'm going to take a look at one lock at a time, and we'll start with the 4-digit combination. So for this 4-digit combination lock, you can choose 0 through 9 for the first position. You can choose any number 0 through 9. So you have 10 choices. You can count on your fingers. Starting at 0, 1, 2, 3, and so on, there's 10 options to get from 0 to 9. So there's 10 options. For the second combination point, there are 10 options. There's 10 options here, and there's 10 options for the third one, and 10 options for the fourth one. So what we want to do whenever we look at a combination like this is the number of possible solutions for the number of possible 4-digit combinations here, you multiply your choices. So you multiply your 10 options here with the 10 options here, with the 10 options here, and the 10 options here. So you multiply your 10 different options for each spot. You multiply those together, and you get the total number of possible combinations for the lock. So because it's 10s, we can probably do this math in our head. 10 times 10 is 100, and 10 times 10, like I said, is 100. So you do 100 times 100, and you can see that there are 10,000 possible combinations for this lock. So you have a 1 in 10,000 shot every time that you try to break into this lock. So if someone's going to break into this, there are potentially 10,000 solutions that they would have to try, 10,000 combinations before they could get your combination. So let's use that same logic and look at the other lock. There's now 5 different possibilities. So I'm just going to pull out for each one. It's the same type of lock. There are 10 different options for the first slot, 10 for the second, third, fourth, and fifth. So I'm going to multiply all my possible options. So 10 times 10 is 100. 10 times 10 is 100. And we multiply that product by 10. So we do 100 times 100 because we did that already, and we got 10,000. Now you multiply that by 10. Just with the addition of that last slot, we have 100,000 possible options. We went from 10,000 for this one to 100,000. This is 10 times more secure, and there are 100,000 options just by adding that last digit position. So just imagine how secure something like this would be. This is called a cryptex. It was invented by Da Vinci. Instead of numbers for each slot, there's 26 letters of the alphabet. So just using that same logic, can you imagine 26, not times 5, times 26, 5 times? That's how secure this is. Can you guess how many possible combinations there are for this cryptex? There's actually almost 12 million possible solutions for this cryptex. So exponents we see in real life for a lot of different ways, but I thought this one was most interesting because this is how we keep things secure and private in our society. We think about creating a password for your computer. Think about the requirement to add a capital letter or to add a symbol. If you have to add a capital letter, a symbol, and a number, your password is going to get exponentially more secure. So this is a recap of everything we've learned so far, and we're not done yet. We're almost there, but we're going to keep going through this real quick. Let's just review, and this is something I would have you write down. So you might want to use this on your quiz or on your test or whatever. So number one, every number has an exponent. If it doesn't say, it's a 1. So even this 1 right here has an exponent of 1. It's just invisible. This number over here to the side is a big 5 with an exponent of 3. So 5 is the base. I wrote down the base is the big number. Base and big. I'll start with B so you can remember that. So this is the base. And the exponent tells you how many times to multiply the base. So the exponent is your little flower. It's that little guy. That right there is the exponent. Right now, this is written 5 with an exponent of 3 in exponent form, but in expanded form, we know that this is 5 times 5 times 5. The exponent tells you how many times to multiply the 5. So this is not 15. A lot of people will say, oh, well, that's just 15. No, it's 5 times 5 is 25, times 5 is 125. So it's actually a really big number. So let's add on to this. So when we were looking at exponents before, we might have seen, maybe with area, we would have seen like a 5 with an exponent of 2, and we would have said that's a square, or 5 squared. So we have some new rules for an exponent of 3. If you have an exponent of 3, you could say this a few different ways. You could say 5 to the third power. So this is 5 to the third power. I like to think of exponents as like really strong things that make your number exponentially bigger. So they're pretty powerful. So I always like to think this is going to be 5 to the third power. You could also switch it around a little bit and say this is the same thing as 5 to the power of 3. So you could say 5 to the third power or 5 to the power of 3. And you can say this for all numbers, not just with 3s, but this last one is specifically for 3s. So when we think of squares, we think of area. Whenever you see a little exponent of 3, you probably have already seen that when you're talking about volume. You might have called this 5 cubed. You might have also seen this as inches cubed or centimeters cubed or cubic inches or cubic centimeters. That's when you're talking about volume or 3D shapes. You would write that as 5 cubed or read this as 5 cubed. So these are all 3 acceptable ways to write 5 with an exponent of 3. And then just to recap, in case you didn't already, I'll go ahead and change this to a 2, and we'll take out one of these 5s. and you have the same thing here, how to say 5 with an exponent of 2. You could say 5 to the second power, 5 to the power 2, or you could say 5 squared. After 3, there are no special words, so I'm just going to show you real quick. If I had a 4 here, this is just 5 to the 4th power, 5 with an exponent of 4, or 5 to the power of 4. There's no special words for it after that, but the same rules would apply. You would multiply the 5 by itself 4 times. So you would end up with that 625 means that this is fully simplified. So you can simplify exponential expressions. That's a lot of fancy words there. It just means do it. Just do the math, make it easier, type it in the calculator, and it would come out to be 625. So we've got a lot of information so far, but let's go ahead and apply some of that information to some practice. Let's go ahead and look at some of these expressions written in expanded form. Let's go ahead and write them with exponents. You can take a second, pause the video, and try all these by yourself, and then whenever you're ready, press play and watch me go over it. Okay, so you should have just tried at least one of these. This first one I want to look at, it's got a 51 times 51 times 51. So what I always do whenever I look at these is I always just get in the habit of writing all of these with their little invisible exponent of 1. I always want to do that because it helps me remember that these all have an exponent of 1, and I'll show you why that's important later on. But we always start by writing the base number. So there's a base of 51, and there are 3 51s being multiplied. 51 times 51 3 times. That means that my exponent is 3. I could say this 3 different ways. I could say 51 to the 3rd power, 51 to the power of 3, or 51 cubed. Let's look at the next one. It gets a little more difficult. Let's identify our bases first of all. So we want to identify our bases. I have a base of 53. I have a V base, so variables can be bases, not just numbers. You can have variable bases. And then 36 is a base. So those are 3 different bases. So what I'm going to do is I'm going to go ahead and pull those numbers out. And remember, I say this is a number. That's because a variable is a number. It's just an unknown number or a number that is changing. So what I do next is I always want to go ahead and I just write out that each number has an invisible 1 of an exponent. If it doesn't say it has an exponent of 1, and that will be important later, I promise you. You might have already started to see the pattern with this 51 in the first example. But what I want to do now for this one that I'm on is just go ahead and count how many 53s there are. I only see 153, so I know that this is 53 to the 1st power. Now I'm going to count my V's. I see a V and I see another V. So there's 2 V's being multiplied. So this is V to the 2nd power. Remember, you could say V to the 2nd power, V to the power of 2, or V squared. I also see that there's a 36 here. 36 2 times. So 36 to the 2nd power. So there are 3 different bases being multiplied. I can't combine these anymore. I'm just going to leave it like this. If I was going to fully simplify this, I could go ahead and do 53 and I could multiply that by 36 squared, but I'm not going to do that right now. I'm just practicing writing these expressions from expanded form into exponent form. So if you haven't already, go ahead and try this last example, then press play when you're ready for me to walk you through. Okay, so you should have just tried that or tried it already. What I want to do is I want to just go through and I want to identify what are my bases. So I have a base 9. I have a base of 95. That's a different number. 9 and 95 are 2 different numbers. And I have a base of W. So those are my 3 different bases. Now I want to identify how many times they're being multiplied by themselves. So let's see how many 9s there are. I see 2 9s, so I'm going to write 9 with an exponent of 2. Remember, I can read that 9 to the power of 2, 9 to the 2nd power, or 9 squared. You would not say this as 9 to 2. You would not say this as 9 2. This is not 92. This is 9 to the power of 2, 9 with an exponent of 2, 9 to the 2nd power, or 9 squared. Those are your options. Let's go ahead and look at the 95. There are 2 95s, so the same thing for that one, 9 to the 2nd power. And then there's 2 W's being multiplied. Remember, this only works with multiplication. So this is W squared as well. This is only with multiplication. This would not work with addition. This only works with multiplication. The last thing I want to talk about, and this is the very last thing I want to go over, it's just what to do with this negative. So bases can be negative. You can have a negative base. What I want to show you, though, is the difference between this -5 without parentheses and this -5 inside of the parentheses. And for me, it all has to do with your PEMDAS. So remember, parentheses, exponents or square roots like we've learned now, multiplication or division, whichever comes first, and then addition and subtraction, whichever comes first. So what we learned way back when is that A minus or a negative outside of a number really means the opposite of that number. That's like talking about addition and subtraction. We learned the opposites when we learned about addition and subtraction. We also could have thought about this as multiplying it by a -1. We can think about it like multiplication. This is the same thing as -1 times this number. But either way you look at it, we look at minuses and negatives over here. We look at exponents before we look at the negative. The only difference is that in the parentheses, you would multiply the whole thing. So let me show you this one on the right first. So let's look at this one. This is a -5 two times. It's in parentheses, so it shows you that this quantity of -5 is being multiplied by another -5. A negative times a negative is always positive, so your answer would be positive 25. Well, let's compare that to the one on the left, and this should make more sense. The exponent comes before the multiplication, the division, the addition, or the subtraction. So we don't worry about the negative as long as there's not a parentheses. Remember, parentheses would come above in PEMDAS. So there's no parentheses. So I do 5 squared first. This is just 5 times a regular 5. 5 times 5 is 25, and then I bring down that negative. That negative is still there, and it's just the last step. It just means the opposite of 5 squared. The opposite of 25 is -25. So do you see how these are totally different numbers? The one on the right with parentheses gave me a 25. The one on the left gave me a -25. So you really have to pay attention to your signs. You have to pay attention to your parentheses. And if you're using a calculator, make sure that you type in your exponential expression exactly as it's written. If there's parentheses, use them. If there's not, don't put them. So these are all the rules so far. You might want to just go ahead and jot these down, keep those, study those. We also just learned the importance of the parentheses. If you put negative regular 5 squared, and then you have a parentheses -5 squared, you're going to have different answers. So you want to make sure that you're paying attention to the parentheses. I also want to just tell you real quick that on the keyboard, if you were going to type this in online, usually there's a tool for this, but you might also have to use this up arrow, this little caret arrow. This is on a calculator or on the computer to mean exponent. So on the computer, you might want to type that in. If you were going to type this in the chat somewhere or something, you would write 5 caret 2, and that would be the same thing as 5 with an exponent of 2. All right, guys, that's it. If you made it to the end of this video, please put which season is best in the comments. So spring, summer, fall, or winter. Today we went over exponents and all about them. So we looked at all the basics of exponents and the intro to exponents. So now you should be able to write expressions in exponent and expanded form, and also do a whole lot more stuff with exponents. So go ahead and go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.